Hi students, Miss Walsh here, and today we're going to take a look at regression functions and the coefficient of determination. So you remember that a few days ago we did linear correlation and we found the R value. Remember that was called the Pearson's correlation coefficient. And the coefficient of determination is the squared of that value, but it has a slightly different meaning, okay? Remember that the Pearson's correlation coefficient, the R value, is only applicable to linear models. And models aren't always linear, right? We're going to take a look at a couple of examples today that are best fit by other functions than a line. And of course, you've already seen that in things like the population and the COVID-19 modeling that you have done. So to be clear on the meaning of this, there's more than one, and the coefficient of determination is the proportion of variance in the dependent variable that is predictable or explained from the independent. Now I realize that that's confusing. What it means in layman terms is it's basically the percentage of variation in the y that it's explained by the x, okay, and the rest is explained by something else. Another explanation for it is in the context of regression, which is what we're doing, right? Regression means using the calculator to find the function best fit, is basically the R squared showed us the percentage that is fit by the regression function. So it's basically how well our function fits. Okay, so we're going to start with this example right here, and we've got a patient that takes a drug in the form of a pill, and then we've got a data that's collected, and we look into the bloodstream of the patient from the time he takes the medication, find the time measured in hours, and the concentration measured in milligrams. And what we need to do is we need to determine the regression equation that would fit this, and then the coefficient of determination. Okay, so this is a two variable data. So we're going to go and we're going to put our data in. So go ahead and pause it and make sure that you put it in as well, because just watching it will not quite settle. Okay, if I hit plot, I have some sort of a problem, and I do this on purpose so that you guys can problem solve as well. Okay, we're going to go to symbol and notice that I have something else here, okay? And what I need to do is I need to put, just double check, yep, C1 and C2 is what I need, okay? Now, if I just hit actually backspace, it defaults to C1 and C2, which is rather wonderful. So now I can go ahead and plot my data, and if we don't see it, okay, 1 second, I need to quit this and then start it again. My calculator likes to do this. Okay, you're not seeing it on the screen, so just go to view and then go to auto scale, and there it is. Now, what you can see is this data is not linear at all, okay? Remember, you always want to see what it looks like first, okay? So even though if we go to the data, if I want to, I can now just hit stats, and it will give me my R, my correlation, 61% of correlation between the X and the Y, and it gives me the fact that the line of best fit has about a 38% fit. But of course, when you look at this is not significant. This is not linear behavior, right? Keep in mind what we're looking at. We're looking at the amount of medication that is found in the bloodstream, right? So after the patient takes the pill, what ends up happening is the medication seeps into the bloodstream, and then once the body processes it, it goes back down, okay? Now clearly, hopefully you can see this is quadratic, okay? So what we're gonna do now is we're just gonna get a quadratic fit instead. So we're on C1, C2, and then we're just gonna go to, let's find our quadratic. Okay, there we go. Yep. And then when I hit plot, you can see that this is a much better fit. And if you go back, there's the equation. And now if I go back to my data from there, that's where you want to hit the stats from. You can see that actually our R value is, so the R squared for this is 986. Okay, so what that means is we actually have about a 99 95% fit by the regression function. Okay, good. So that's it. Yeah, we graphed it and we found the coefficient of determination. Let's take a look at one more. So this is a ski jumping situation. And in order, ski jumper is illustrated on a diagram. And in order to determine a function, the diagram was processed with a graphing software. So what they've done is they've taken a picture, and you guys actually have done this in grade 9, haven't you? When you were doing the parabolic project and you had to go tick, 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 and get a bunch of dots. So that's what happened here. And as you can see, here, the quadratic is not going to be a very good fit at all. All right, let's see what happens. So I'm going to go to back to my data. And as you can see here, just to make the podcast as short as possible, I've already plotted my data. Now I have plotted in C4, C5. So just pause it and go ahead and enter these values. And as you're doing that, just to make sure that you're clear why these y's are negative, always take a look at how the variables are defined, okay? So in this case, what they said is x is the horizontal distance from the starting point, and then the y is the vertical displacement from the starting point, okay? So the ski jumpers, they come over here, and then vroom. Okay, so all of these are below his starting point. So he goes down, and then he comes back up, and then he goes down again, okay? So you can see that this kind of looks cubic, right? Cubic function. Okay, so once we've entered this, we're just going to go back, C4, C5 for me, maybe something else for you. And I'm just going to actually specify that, okay? C4, C5, and then I'm not going to change this yet. I'm going to plot it. It's not showing up, and I'm going to try the auto scale. Sometimes the auto scale can fail us, so you can see that this is not a very good fit. And I can see, and by the way, if you don't see the line, try this fit. Fit hides it, fit shows it. Okay, so I'm going to go back and change it to a cubic. There we go. Let's give that a try. Okay. Ta-da! Wow, what a great fit. Let's just see. So now make sure that C4, C5 is there, because now when you hit stats, he knows what to do. And look at this. This is an almost perfect fit. And so here our coefficient of determination is going to be 0.995. So we have over 99.5% fit by the regression model to the raw data. By the way, this is from Wikipedia, and I just realized that I did not source it. Guys, whenever you take something on the internet, always source it. No matter if you're a student or a teacher or what. Okay, so that's it. And now you're going to go and practice a few different regression functions and see which ones fit. But remember, you learned this from the Ascombe's quartet. Always graph the data first. Bye.